Let's look at worked example 7.7. The first step in the industrial synthesis of hydrogen is the reaction of steam with methane to give carbon monoxide and hydrogen. Write the equilibrium equation for this reaction, capital H subscript 2, capital O, parentheses G, end of parentheses, or water vapor, plus capital C, capital H subscript 4, parentheses G, end of parentheses, or gaseous methane, back and forth arrow, or is in equilibrium with capital C, capital O, parentheses G, end of parentheses, or gaseous carbon monoxide, plus coefficient 3, capital H subscript 2, parentheses G, end of parentheses, or 3 moles of gaseous hydrogen. Pause the video to do this. Looking at the balanced chemical equation, we see that each chemical is in the gas phase, which means that each chemical will be included in the equilibrium expression. The products go in the numerator and the reactants go in the denominator, and each chemical has a coefficient of 1 except for hydrogen, which has a coefficient of 3. The expression reads, capital K is equal to the ratio of brackets capital C, capital O, end of brackets, or the concentration of carbon monoxide, next to or multiplied by brackets capital H subscript 2, end of brackets, superscript 3, or concentration of hydrogen to the third power. It doesn't matter which of the reactants, which of the products comes first. This is all over brackets capital H subscript 2, capital O, end of brackets, or concentration of water vapor, next to or multiplied by brackets capital C, capital H subscript 4, end of brackets, or concentration of methane. Again, it doesn't matter which reactant comes first, as long as each reactant is in the denominator. Coefficients of 1 are not expressly written as powers, but all other coefficients are written expressly as powers. The ratio of products to reactants at equilibrium at a given temperature is constant. There is some number that K is equal to, although this problem just wants to give you practice writing out the expression.